Hello class, today we'll be talking about conditional probability a little bit more in detail. Most likely a topic for this entire week will entail a conditional probability, nothing else. Yesterday we have done these questions and I asked you to do these three problems as homework questions, so I'm going to go over these first. For probability of male, we're talking about a random student, chosen student. So what that means is that you're gonna have to add up the totals like how I have done before. So when you're always given the table format, please understand that your first step is to always find the total in each of the columns, each of the rows, and things like that. So here, I'm gonna find out the total for the male. It will be 40, 16, and 35. Altogether, that will give me 56, so that will be 91. These all together, that will be 59. So in total, I believe that's going to be 150 people in total. And if I add up this way, 55, 40, and then 55 again, and that will also indeed come out to be 150. So the probability of male is 91 out of 150 because it's total number of males out of the whole thing. Second, the probability of male or majors in chemistry. So we're talking about male, and then we're talking about chemistry. And now notice how this 35, okay, this 35 is the one that's being overlapped. If you remember from last time, we say that the probability of A or B, the U shape is actually meant to be or I will just write or in that case so that you guys know, would be probability of A plus probability of B minus probability of A and B happening at the same time for what we call a mutually non-exclusive or non-mutually exclusive events. The reason why it's not mutually exclusive is because they're both completely inclusive part for both male and chemistry people, which they both being shared. So we cannot say that this is perfectly mutually exclusive event. So what that means is that the probability of finding male, which is 91 out of 150, that's probability of male, plus probability of chemistry, which is 55 out of 150, but you need to subtract away that one portion that's both chemistry and male, 35 out of 150. So if you put that in the calculator, I believe you will get 111 out of 150. Or you can just simply take 91 and add 20 to it because you have to exclude 35 from the previous one. You will still get the right answer at the end. So this answer would be 111 out of 150. Now, the last part is what we have been talking about yesterday, where we have probability of A given B. Well, we found out that the formula for that was probability of A and B happening at the same time over the probability of B. This is how the way that we say it is probability of A given, the word here is given B. So, when we say that the majors in physics, given that the probability we're choosing out of the people that's only just male, is that we need to first take a look at the table and we go, how many people are physics and male? It's this guy right here. That's 16 out of 150 because that's both physics and male. Now the probability of B, well, that's probability of just male. So the probability of that's just male is 91 out of 150, which was your answer from part A, as we have already found out. 150s will cancel each other out, so your final answer would just be that, which is 16 out of 91. Hope you had those three answers on your homework. And that's going to be it for conditional probability homework from last time. Now for today, what I want to show you is, I wanted to go over a question that looks like this, and I wanted to do a homework questions based on this, which is all strictly just finding the given probability or conditional probability. Okay, so here again we have three conditional probability questions, and we're talking about also something very interesting. It says probability of integer. Now this is called a sample space. The reason why I didn't give you this yesterday is because I figured that this is not something that we're used to. We're so used to seeing a table scale, but what if I were to give you a bracket scale like this? So basically what this means is that a sample space is a given thing or a playground. The playground that we're going to be playing. It's a map. If you're ever playing a MOBA or first-person shooting games, it's basically the bottom right corner. There's usually like a map, right? That's the entire playing ground that you can utilize. So this is the entire playing ground that we're going to be utilizing, and there's going to be a couple of elements. Let's say that our sample space is our geometry class. Then we'll have all the members of our current geometry students. So student A, student B, student C, student D, etc., all the way to student, let's say, Z. So we have 26 students in our classroom. Then we can say those are my elements. Each of these are called elements, in which it makes the components of this sample space. So in other words, these are the students, and that makes up our classroom. Okay, so I wanted you to kind of think of it in that scale. So now what I want to do is I want to count how many elements are there. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's total of how many numbers would that be? That's going to be total of 10 numbers. Okay? All right, so out of these 10 numbers, how many of them are integers? What is an integer? Integer is basically a number that has no no decimals or fractions. If you take a look, all of these elements in the sample space, they're all integers, right? So out of these 10 numbers, out of these 10 total elements, how many of them are integers? All 10 of them, which is 100% of them are going to be probability of integer. So what's your probability of picking an integer out of this sample space would be just that. Next, probability of picking that's less than 10, given that it's less than 13. So this is probability of A and B, given the probability of B. You can think of it that way. Or you can just simply count. Counting would be the easier way to do this question because we have the list of numbers to deal with. So we're talking about less than 13. So out of these number right here, so that's how many in total? That's only 9, not 10 because 14 is excluded. Out of these 9 numbers, how many of them are less than 10? Well, let's count. Oh, actually, I'm sorry. Less than 13 means that you start from 12, so it should be out of 8. Less than 10 will start from 9, 8, 7, 6, 5. So those 5 numbers right there. So it should be just simply 5 out of 8. Next question. Greater than 8 and less than 11. So I'm going to erase all this right here. So first of all, we want to find out how many of them are less than 11. 10, 9, 8, 7, 6, 5, that's 6. Like I said, it's better to count because we have the list of elements. Greater than 8. So how many of them are greater than 8? 9 and 10. So it's 2 out of 6, which is 1 out of 3. Okay? Pause the video and try to see if you can do part D on your own right now. Pause the video and then play it again once you're ready. Okay, so assuming you have it, greater than 12 means 13 and 14 out of these 2. How many of them are greater than 7? Well, both of these are still greater than 7, right? So it's actually 2 out of 2, which is 100%. So think about it. Out of the only number that's greater than 12, what's your probability of also being greater than 7? Well, these are 13 and 14. Are these also both greater than 7? Well, absolutely. So it's going to be 100% of the time that this statement will hold true. Okay? All right, so at this particular case, the entire review is done. But I want you guys to finish this for homework for today. High school students in one school chose their favorite leisure activity. Find each probability, round to the nearest tenth of a percent. For this, you may use Google Docs. What I strongly recommend you to do is first always make a little total row here and total column here. And your final total here. I know that part B is kind of getting in the way, but you could just work on a separate piece of paper. But add up all of these numbers this way as well as horizontally, and then get your final number. Then do part A all the way to part H. Let me help you with part A to help you get set off for this. So we want to find out the probability of people playing sports given that it's a female. So we are talking about out of just female people, how many of them play sports? Well, I got my numerator number right away, which is 39. But I want to know what's that number because the entire total number of female is what I'm going to put down as a denominator, right? So it's 39 plus 48, which is 87, 172, 234, 305, and 334. I believe that's my total number, if I'm not mistaken. So just to verify, I'm going to use my calculator. I should probably have done that in the first place. Yep, it's 334. So that's going to be the number of female And out of those people only, how many of them play sports? Well, that's 39 of 334. Okay, so please finish from part B through H. That's 1, 2, 3, 4, 5, 6, 7 questions for homework to do. I'll post this as a PDF file just like before. Remember, guys, you may use Google Docs, but I still would prefer to see if you can do some notes with this by drawing out the table and write down all the total for me, and then using that table. Actually, never mind. I'm not going to allow you to use Google Docs. I'm going to ask you to draw out the table specifically and then write down the total for me and then do it that way. Okay? Please show me the work. And finish this by, because it was a little bit later than usual, I'm going to post this until maybe 11:59. But it should be a pretty fairly easy task to do, and hopefully I'll grade that for today, and that'll be it. Thank you, and have a good day.